There is a great news for Flutter developers. Now you can become a full stack AI developer just using Dart language. That means you can use Flutter for web application and mobile application for the UI purpose, Dart for the server endpoints, and Dart to create and generative AI apps or agentic AI apps using Genkit framework. Few months back, Dart team has already announced that Dart is being used in the cloud function that's soon to be released. That means you can write your code in the server endpoints just using Dart without using any frameworks or deployment problem. And now the Genkit and the Dart team has announced that they are releasing a preview version of Genkit Dart SDK. So Genkit is used to create AI powered apps, whether it's a AI agent, RAG, MCP, tool calling. So those kind of AI tasks can be done with the Genkit. Genkit is an open source framework by the Google and it can run anywhere. That means if you want to choose Google Cloud or Amazon or Azure, it depends upon you. You can choose this agent and run anywhere. So what comes with Genkit Dart? So model agnostic API. That means with the single function or class, you can call Gemini, Anthropic, Claude. You don't have to use SDK of each LLMs. There is a single unified API is given and you can just call that, mention the model name and that will work. Type safety. We already know Dart is a type safe. Developer UI. So it gives a localhost web UI to test our agent on a local system before pushing to the production. In this video, I am going to show you how to do this. Run code anywhere. That means once you create an agent using Genkit, you can deploy on any server of your choice. So Dart language has come so far since last few years. So Dart started as a cross-platform language, then it goes to the server and the backend code. Now you can use any LLM models. You can run this code on Cloud Run or Cloud Function or as a server app. Now there is an AI framework. Genkit is an official support while there is a language available in the Dart, but that is a community driven, not an officially available from the LangChain, but it also does the job. Then there are vector DBs. Firestore and Superbase have vector. That means you can write your code to generate embedding, store it, and perform a retrieval using these embedding DBs. Then we have on-device AI. That means you can run small language models on the mobile offline using Dart language. The libraries are available on the PubDev. And server-driven UI, the stack. That means you can control your UI from the backend, depends upon the conditions of whatever the config you want to set on your server. And agent to UI. That means agent can control what kind of UI should be pop up on the front end side. And there is a library available in the Flutter too. We will discuss that in another video. In this video, I am going to create a simple weather agent. So there is an application which will hit an endpoint get weather with prompt where user will ask what's the weather of this city name. So this endpoint we are going to create using Dart self package that is used to create a server application using Dart. Then we will deploy this server on Google Cloud Run that will create an endpoint that is publicly available. And then we'll use Genkit AI framework to create our agents. So when a prompt will be inserted to the Gemini model, it will check whether the tool need to be executed or not. That means a weather tool. So if yes, it will fetch the latest information of that city from the weatherapi.com, return the information and return the result back to the user interface. So let's start. Now I have already created a playlist on the Genkit series where I have created a HR agent using retrieval augmentation generation. So make sure you subscribe this channel and follow that playlist. My all Genkit video will be uploaded on this playlist. Now before we get started with the coding part, we need to have prerequisite of few SDKs. First is Dart SDK. So Dart SDK need to be installed on your system and should be available via command line interfaces. So next step is to install the Docker in your system. So I am using Windows OS. So I am going to use Docker desktop application. You can follow the instruction how to download in the Mac and the Linux environment via command line interfaces. We are going to use this Docker to deploy a server on a local host and test our application before to the production. Then you should install Google Cloud SDK, that is Google Cloud CLI. So we are going to deploy our backend service to the Google Cloud Run with the help of Google Cloud CLI. After you install the Google Cloud CLI, type this command Google Cloud auth login. This will open a browser to ask a permission to access the Google Cloud console of your email ID. Allow those permissions. Next step is to create a Google Cloud project. We need this to get the Gemini API key to trigger the Gemini LLM conversation, and next to deploy the service on the Google Cloud Run. So here create a new project. Here I have created dev project. Then go to enable services. Click enable API and services here and enable APIs for Gemini. So enable both Gemini API and Gemini for Google Cloud. After enable the API, go to credentials, click create credentials API key, type here Gemini, and here restrict using Gemini for Google Cloud API. Click OK and create. This will generate a new API key, copy it and save it in a secure place. Now, in case if you are having any problem creating Gemini API key on the Google Cloud server, you can also use Google AI Studio. So open the Google AI Studio, go to get API key, and here create a new API key. Here you can copy the API key to be used later for the same Gemini API usage. Next is we need weather information. So for that I am using weatherapi.com. This website provided free services up to a certain extent to fetch the information according to the city name and location name. Create an account on this website and this will generate an API key. We are going to use that later. So now we go to the Genkit official documentation and see the Dart usage. So where have we have to execute this command dart create -t console simple and the app name. This will create a simple CLS based application. I've already created the app. So this will create one bin folder and one pubsec.yaml. Now open the pubsec.yaml and add these packages Genkit, Genkit Google Gen AI, HTTP, semantic, shelf router. So first we are going to make our agent first, and when it's working, we are going to wrap this agent with self router to create a server API endpoint application. So create a new folder lib, and here we are going to write our Genkit application. So now I am wrapping this in a main function, so I can run this agent independently without the self package. We are going to remove this main function later. So first thing is to initialize the Genkit application. So final AI Genkit, and here as a plugin I am using Google AI. Google AI is used when you are using Google AI Studio or Gemini API. If you are using Vertex AI, then you have to use Vertex AI function here. So this almost never happens, but in my PC localhost was not working properly. Some ports were blocked. So for that purpose I use this way to get the Genkit reflection port via the environment and set it in the Genkit. Now second task is to define the tool. That means if user asks a question, what tools need to be executed. So here I'm going to define the tool. This will not execute at this point. This is just for the definition. And then we define a flow. Flow in Genkit is like which handles the pre-processing and post-processing part and getting the output after the process and return back to the server or Firebase. And within the function, we will write our actual logic that need to be processed, whether it's an API call, database connection, or a generative API. So let's see weather flow first. So I have created a defined flow here, weather flow, and I have given a unique name weather flow. This is necessary to give a label to each flow, and each tool should be unique. Then I have added the input schema. That means this agent is accepting an input only as a string type, and I have given a description. This description is only for AI to understand, not as a developer point of view or a documentation. This information is being sent to the AI. The output schema, that is after the processing is done, the expected output is in the string format. If I click here, you can see you can change the output depends dynamic, map, boolean, integer, list, or nullable. So we can set different types of data as an input and output. So next is the function. So input schema will be passed in the user input. That is whatever user has sent to the agent will be available in the user input. It can be a string, map, or list. Depends what type of schema have you mentioned here. So our user input will be in the natural language. That means user can ask what's the weather and temperature in London. So those queries will be in natural language form. So we have to use a model to understand the user intent and extract the information. That means which city user is asking the weather about. So I am using Gemini 2.5 Flash Lite model. You can also use Gemini 2.5 Flash or Gemini 3 Pro. But for a simple weather agent, Gemini 2.5 Flash Lite is enough. If we are going to have a conversation, analysis or image generation, then we can use Gemini Pro here. So I am going to use AI.generate. So AI.generate and define flow are similar in Genkit. They are specifically used for pre-processing and post-processing, and also it helps in tracing what goes in the input, how much time it takes, what was the output has been given, what if there is an error. So all logs are mentioned if we use these flows. So we have passed the Gemini model here, Gemini 2.5 Flash. Then prompt, you are a weather assistant. Your job is to read the user input, extract exactly weather location, that means the city name. If a valid city name or latitude longitude is present, call a weather tool exactly once. That means user can pass a city name also or the coordinate of the city. Both can be passed to the weather API. Pass only the raw location string to the weather tool. So we need only a single string, whether it's a city name or latitude comma longitude format as a string. So I have given a few short example here. So here LLM will extract the city name and longitude and give us the output in this format: query and the parameter, query and the latitude and longitude. And here is the user input. So here I have passed the user input. So whatever the input is provided by the endpoint, I have passed directly as a raw string here. And then there is a tool function and attached a weather tool. So LLM will generate information using this information. The parameter will be like this. These parameter will be passed in the weather tool automatically. After getting the weather of that particular location, the information will be returned back to the Gemini and it will return a natural language response like here is the weather of the Mumbai or something like that. So after generate function is executed, the response will be returned in the response object, and here as a response of text we will get a text information. Now for the tool, we are defining a tool here. We are telling the Genkit that this is a generative AI part where LLM is being used to generate a responses, and this is a tool. That means it's a function. It will take input, execute something and return an output in a definite format. So I have defined a tool, define tool. This is also a flow of the Genkit. All these AI dot are the flows class defined in the Genkit SDK. So I have given a unique name, weather tool here, and a description. This description is for the LLM to understand what this tool is doing. So the task of this tool is get the current weather of a single location. Example, if a function is passed query Delhi or function has passed query with the parameter of latitude or longitude, this will return a weather of a single location. Then we are telling the LLM then the only input acceptable by this tool is in the map format, where the key will be in the string format. The key name will be query and this will be a string format, a description, and the value will be also in the string format, query field value. This is a description simply. So after we hit the weather API, it will return a large JSON object with the temperature, humidity, and everything else. So output schema says we will get a map object where key is the string type and the value can be anything. It can be integer or string or a list of objects. So we have mentioned this dynamic schema at this point. So when this AI generate will trigger the weather tool, a parameter will be passed like this. Suppose query Delhi. Then this map will be passed here, that is the map object. Now this is a simple weather API service that I am using to fetch the weather information. So I pass the input query map, that means Delhi will be passed in this function. So if I click here, so you can see this is a simple HTTP response. So this is the base URL. I am fetching the weather API from the environment. Now we're preparing the full URL. So this is a base URL for the weather API. Then we are using query parameter. So key parameter is used to pass the API key, and the queue parameter is used to pass the user input, that is either the city name or latitude longitude in the comma format. We hit the HTTP get API and we get the response and return as it is. So we are not going to pass this information. LLMs are smart enough to extract those information that is required. So after this value is returned, you can see output schema is string and dynamic type. This tool will return back to the generate, and generate will process this information and generate as a text. Now let's test our agent. So one thing I missed, Before running this, we need to install Genkit CLI on our system too, not just as a package, but as a CLI. So run this command to install the CLI on the system. Now set the environment variable like this. So I am using Windows. This is the method. If you are using Linux or Mac OS, use source method or export method. So first use the variable Gemini API key and pass the value here. Click enter. Then use weather API key like this and click enter. So both environment variable will set. We will see how to set this in the Docker too. Now run this command. Jenkins start Dart run because it's in the lib folder flows. It will start the localhost at 4000. Click here and it will open a Genkit developer UI. So here we can test our agents developed in the Genkit. So go on the left menu. So here we can see there is a models available. So we can change our models here to test out our agent. We can change the temperature, top P, top K, and all the configs can be tested here. So we are going to use flows. So you can see there is a weather flow available. So if your flow is not showing in this list, that means there is some issue with the code. The flow should be mentioned here. Now in the input user, I am going to type what's the weather in Mumbai, run. Output is generated. Weather in Mumbai is currently overcast, temperature is this. And if we go in the detail here, you can see all the traces. What was the input, what is the output, then the generate function were executed. This was the input in the generate function and output. Then the model was used, what the model received and the what model sent the output. You can see the first the model received the input like this, what's the weather in the Mumbai, and model generated an output for a tool request with the query and the Mumbai parameter. This query is passed in the weather tool. So query was Mumbai, simply the city name, and we get these information from the weather API. And this whole JSON was passed back to the Gemini 2.5 Flash. It's smart enough to understand what's the information we need. So it discarded all the information and focused on the temperature in degrees Celsius and return the response in the natural language format. So that means our agent is working fully. Now we are going to remove this main function. This is for testing purpose only. Now we are going to create our server endpoint using self package. So go to bin app. There is a main function that is the entry point our server. Type router here, router get parameter get weather. That means our get weather endpoint will be of get method. We extract the city name, the parameter that will send will be city. We are validating the query parameter and then we are going to pass this city in the weather flow. If we click here, you can see this weather flow is same. So this is just a function where we pass the city and this city will be passed in the input schema. That means it will be available in the user input, and from here the flow will be same that we discussed previously while using Genkit developer UI. And after getting the response in the simple text format, this will be returned response okay, content type text plain. Then we are creating a middleware here. That means all the requests will go from middleware to the API router. So router will handle the endpoint. And to start the server, we use io.serve handler. We pass the handler object, internet address, our local IP address, and 8080 IPv4. And the server will start. Now we are going to use Docker to run our server. So create a Docker file here and enter these commands. So I've used this Docker file exactly from the official Docker image that is available on the Docker website. Dart from stable build working app directory pubsec pubget. We are compiling our Dart into the executable format, that means exe format. Then we are moving the files, exposing the 80, and then we are starting our server like this. So now let's run this Docker on our local system. So I started the build process, creating an image of this Docker server. Now to run the local host, type docker run -p 8080 environment variable Gemini API key, our API key, then -e weather API key, the API value, and the agent of the name that we passed here, weather agent. Click enter. So now server is running. Click route not found, no issue. Type get weather. What's the weather in London? Enter. The weather in London is partially cloud, temperature is 6.3, it feels like 2.8, and wind is blowing with this. So that means our endpoint is working and our agent is working, all working on a local host. Next step is to deploy this service on Google Cloud Run. So to deploy this service on the Google Cloud Run, we have already created a project. Copy the project ID from the Google Cloud console and execute this command: Google Cloud config set project and your project ID name. Next step is to type this command: Google Cloud artifacts repositories create weather agent. This name will be created on the Google Cloud artifact registry. Repository name format Docker. That's why we created a Docker file here. Location US Central 1 and a simple description. Simple weather AI agent. Click enter. So after this executes successfully, go to Google Cloud, type artifacts. So in the artifact registry, you can see a weather agent has been created. Okay, that means this process was successful. So the next step is to deploy our code on the Google Cloud Run and make it available via public URL. So use Google Cloud Run deploy weather agent service. This is the name of our application. Source, that is the current directory. Region US Central 1. Allow unauthenticated. We are not using any authentication right now. Set environment variable. So here we are going to set our weather API key like this and Gemini API key like this and click enter. So this will take few minutes to build and upload the image to the Google Cloud Run, and the API endpoint will be available here. Okay, so our deployment is complete and the service URL is given here. You can also check the URL. Go to Google Cloud Run, click refresh here, and the weather agent service is available here. You can copy this URL, type weather agent service, comma, get weather. What's the weather of Lucknow? So the current temperature in Lucknow is 34 degree. Wind is coming at 21 kilometer per hour and humidity is 30%. So congratulations, you just make your first agent in Dart language. Now you can add this endpoint in your front-end application, whether React or Flutter web or Flutter mobile application, and use this as an agent. Check more on this playlist where I've created a retrieval augmentation generation agent which read data from a PDF document. So subscribe this channel, like this video. See you in the next video. Till then, keep learning.